Assalamu alaikum. Welcome. We are going to look at the second gas law, which is the Charles law. Previously, in our last lesson, we looked at Boyle's law, and we said that Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at a constant temperature. And we have seen the graph, implication of Boyle's law, molecular explanation, and some questions concerning the Boyle's law. Now today we are going to look at Charles' law. Charles' law. And the same way we said Boyle's law has important parts. Also, Charles' law has some important parts that you should know. Number one is stating the gas law, how to state the gas law when you are told to define or state Charles' law. Then another important part is the graph. How does this graph look like? The graph of the Charles' law. Then also the formula of the gas law, of the Charles' law, implication of Charles' law, and the molecular explanation of Charles' law. When you're told to state, you say Charles' law, it states that the volume of a fixed mass of a gas is directly proportional to its absolute temperature at a constant pressure. That is how you state Charles' law. Then absolute temperature is measured in Kelvin scale. Absolute temperature is measured in Kelvin scale. Sketch the graph. The graph of Charles' law is as shown below. We have temperature in Kelvin against volume in cubic centimeters. So this is how the graph look like. It originates from the origin here, and it look like that when you are using temperature in Kelvin. Or when you are using temperature in degrees Celsius, this is how the graph look like. It starts from negative 273 degrees Celsius. It starts from negative here. When you are using a what? Temperature in degrees Celsius, and this is the volume. This is how the graph look like. The formula or the expression, the mathematical expression of Charles' law. The formula of the Charles' law as follows: V1 over T1 is equals to V2 over T2, or V1 T2 is equals to V2 T1. That is when you cross multiply this and this one. It simply means V1 times T2 is equals to V2 times T1, where V represent volume and T represent temperature. Then implication. What does Charles' law imply? The Charles' law implies that when the temperature of a gas increases, the volume of the gas increases, and vice versa. Molecular explanation. Increase in temperature of a fixed mass of a gas causes an increase in the volume of the gas. This is because temperature increases the kinetic energy of the gas molecules, hence they move faster. As the particles move faster, this increases the rate of collisions between the gas molecules and the walls of the container. At a constant pressure, the molecules stay far apart, hence increases in volume. That is how you explain the Charles law in terms of the molecular explanation. Then we have conversion of temperatures scales. Then what you should know is to convert degrees Celsius to Kelvin scale, we add 273.